in this part, in this past paper question, we have to know a very important part, right? Everybody has to be vocal and stop me. We have to know certain amount of important part, that what you mean by a strong acid and what you mean by the weak acid. Strong acids are those which completely dissociates. Weak acids are those which partially dissociate. This thing we have to know. Next important thing we have to know is that if you see, when we talk about the weak acids, strong acids, and weak bases and the strong bases, we have to know this chart. This chart is very important. Viva, just message me quickly. Page 362 OP. To know this part. You to know that if you see, when we talk about bases, right? Just remember this thing, that all ammonia and amines, right? Gaia, you had this question. How do we know? All amines and ammonia, they are weak bases. Is it clear? You get my point? Now here I have to add some important things. See, strong acids are what? HCl, HNO3, H2SO4. Weak acids are what? Weak acids are H2SO3. See, the younger brother of sulfuric acid is a weak acid. HNO3 is a strong acid. The younger brother HNO2 is a weak acid. Please note down this. It's a weak acid. Clear? Done this part? And in Coca-Cola, we and in the carbonated drinks, we have got carbonic acid. Black colored Coca-Cola contains H3PO4, weak acid. Is it clear? Viva, are you done this part? Viva, is it okay? This is clear to you? Fine.
Yes, sir.
Viva, thank you so much. Please be vocal, please. Huh? I told you, right? Please be vocal. All of you are brilliant students, right? Just stop me 1,000 times. Now note down this. Can you name a weak base which is a group 2 metal, and can you tell me, Viva? Usually metal hydroxides are strong bases. Apart from this will be coming aluminum hydroxide. Please note down, and magnesium hydroxide, right? These are weak bases. Please note down this. Calcium hydroxide is also a weak base, right? Clear? This ammonia and amine. Now, to to do the question, right? To the question, yes, FeOH whole twice, right? See, Carlota has sent me a message. FeOH whole twice. Very good. Thank you. Please note down, everybody. Aluminum hydroxide, iron hydroxide. We have got calcium hydroxide, right? These are weak bases, right? Very good. Now over here, next part is that if you see that when we talk about the portion of the titration curve, the titration curve is very important for us to know that what is the inflection point. When we titrate acid with a base, we're seeing that there's an inflection point at neutralization. Is it clear to you, everybody? There's an inflection point which comes. This region where the pH suddenly jumps, this is called as the inflection point. Inflection point is a region where the pH suddenly jumps at neutralization point. Is it clear, everybody? The inflection point is a region where the pH suddenly jumps at inflection point. So this is very important for us to know. Now, going to this part, we have to know the inflection point. Strong acid, strong base will be having an inflection point of how much? 3 to 11. Please note down this inflection point, IP. Weak acid, strong base will be having inflection point of 7 to 11. Then after that, I'm writing in red. Strong acid, weak base will be having an inflection point of 3 to 7. See, you can memorize like this. And there's another thing which you have to know is that what is the pH of the salt solution at neutralization. So this is very important. Please try to note down, please. If you see that when we say about strong acid, strong base, right, we'll be having a pH of 7. Weak acid, strong base is stronger. We'll be having the pH at salt solution will be greater than 7, right? Greater than 7. Strong acid, weak base will be having a pH of the salt solution less than 7, right? Strong acid. So inflection point. Now, we have to know this important trick that when you use an indicator, we have to use an indicator. When we use an indicator, we have to see that the pKa, when you have an indicator, the pKa of the indicator should fall in the inflection region. That's the way we tell, right? Because the inflection region is the region where the end point happens, right? The end point, right? End point happens, or the neutralization happens. The pKa of the indicator should be in the inflection region. This is very important. It should be in the inflection region. So this thing we studied just now, strong acid, strong base is 3 to 11, weak acid, strong base is 7 to 11, strong acid and weak base is 3 to 7. So we have to select the indicators in such a way that it falls in the inflection region. Now, if you see that when we talk about the question, the past paper question, this is a very good question. See, we have to know that the first page which I show of the page number 362, we have to know that this is what, this is a weak base and nitric acid is a strong acid. This thing we have to expert, right? Now, if you know that strong acid, weak base will be having inflection point of 3 to 7, isn't it? Guys, is it clear? 3 to 7. So we have to select an indicator where if you take a strong acid, strong base, the inflection point is 3 to 7. So we have to select the indicator whose pKa should fall in this region so that it color changes. What is the pKa of an indicator? The pKa of the indicator is the pH of the solution where it changes color, right? So this is very important, that if you see that we have to take A. Brilliant, right? Please message me one-on-one. Please message me, right? The answer is A. Very good. We could have taken 7. See, but bromophenol blue, bromothiamol blue won't be a very good indicator, right? Is it clear? So this is a very important portion we have to master, that whenever we are seeing the indicators, we have to solve like this way.